This is Mrs. Zappia with Lesson 14, More on the Angles of a Triangle, from Module 2 in Grade 8. Student outcomes for this lesson. Students know a third informal proof of the angle sum theorem. Students know how to find missing interior and exterior angle measures of triangles and present informal arguments to prove their answer is correct. Notes. Students will see one final informal proof of the angle sum of a triangle before moving on to working with exterior angles of triangles. Pause the video and copy the essential question. How do you form an exterior angle on a triangle, and which angles are its remote interiors? Let's start with this rectangle. What properties do rectangles have? So stop and think what you know about the rectangle and write down as many things as you can think of. We know that opposite sides are congruent, and we have one mark on the left and one mark on the right showing that these two sides are congruent, and then 2 marks on this horizontal segment and 2 marks on this horizontal segment showing that they are congruent to each other. We know that opposite sides are congruent. We also know that opposite sides are parallel to each other, so the 2 vertical sides are parallel lines and the 2 horizontal are parallel lines. We know that there are 4 90-degree angles in a rectangle, and that the sum of the angles is 360 degrees. If we draw a diagonal that connects point A to point C, or we could choose B to D, what shapes are formed? So here let's draw that diagonal. And now, instead of having one rectangle, we have 2 shapes, and they are 2 congruent right triangles. What do we know about these triangles, and how do we know it? Well, we know that the triangles are congruent. We can trace one of the triangles and through a sequence of basic rigid motions, map it onto the other triangle. Remember what we know about alternate interior angles. These are parallel lines, and this diagonal is a transversal. So this angle is an alternate interior to this angle, so they are congruent. We know that the right angles opposite each other are congruent, and this angle in the lower left and this angle are also alternate interior, and they are congruent. So we have 3 pair of congruent angles. And we know that if we can map the top triangle onto the bottom triangle, that would prove congruency. Remember that our goal is to show that the angle sum of a triangle is 180 degrees. And we know that when we draw a diagonal through the rectangle, we get 2 congruent triangles. So how do we put this information together to show that the sum of the angles in a triangle is 180 degrees? Well, the rectangle has 4 right angles, which means that the sum of the angles of the rectangle is 4 times 90, or 360 degrees. Since the diagonal divides the rectangle into 2 congruent triangles, each triangle will have exactly half the total degrees of the rectangle, since 360 divided by 2 is 180. Then each triangle has the sum of angles equal to 180 degrees. So now let's take a look at our figure down here, and we have triangle XYZ. And notice that we have a new vocabulary word called exterior angle. And you create exterior angles by extending the side of the triangle. So we extend that side and we create this exterior angle. We extend this side and we create this exterior angle. And we extend the third side of the triangle to create another exterior angle. So the interior angles, we already know the sum of the interior angles, this angle plus this angle plus this one, will equal 180 degrees. So the focus of today's lesson is to learn about exterior angles and their related remote interior angles. Now let's take a look at what we call exterior angle of a triangle. An exterior angle is formed when one of the sides of the triangle is extended. So here we took this side of the triangle and extended it, and that formed this exterior angle. The interior angles are inside the triangle. The exterior angle is outside of the triangle along the extended side. In this triangle XYZ, we have some exterior angles, and let's take a look at our first one, and we'll call that angle RXY. What do we know about the degree of a straight angle? Well, we know that it is 180 degrees total, and we can see that this one is made up of two angles. So we have the exterior angle, RXY, and then we have this interior angle called ZXY, angle ZXY. And these two angles make up the straight angle. And we know that if we add those together, they equal 180 degrees. What do we know about the sum of the interior angles of a triangle? So let's take a look at the interior angles of this triangle. The interior angles. First, we have angle ZXY, angle ZXY. And then another one would be XYZ, angle XYZ. And then the third angle is YZX, YZX. And we know that the sum of the interior angles of the triangle is 180 degrees. So if we add these three angles together, that's going to give us 180 degrees. And we also know that the interior and the exterior over here also gives us 180 degrees. So this is a statement of equality, where these three angles are the triangle sum, and these two angles are angles on a straight line. And we know that they're equal to each other because they both equal 180 degrees. Now let's take a look specifically at angle RXY, the exterior angle. What I want you to notice is the common angle that is in both sides of the equation. We have angle ZXY and angle ZXY. So this interior angle is on both parts of the equation. Well, if we subtract that angle from both sides of the equation, this is what we are left with. We are left with angle RXY, which is our exterior angle here. And then on the right side of the equation, we are left with angle XYZ, which is this angle, plus angle YZX, which is this angle. So the exterior angle is equal to the sum of the two related remote interior angles. Let's write that down. The exterior angle is equal to the sum of the related remote interior angles. So we've got another vocabulary here. We've got remote interior angles. The related remote interiors. Remote means farther away. So here we have three interior angles, X, Y, and Z. The remote interior angles are the ones that are farther away from the exterior angle, and they both share one side with that angle. So here, this angle shares this side, this angle shares this side. So that is the remote interior angles. Let's take a look at number 1. Name an exterior angle and the the related remote interior angles. All right, so we've got our first one, we've already written it down, and that is angle RXY. Okay, so that's this angle right here, RXY. And remember, the vertex is the middle letter. The related remote interior angles are the interior angles that are farthest away from this. So that would be these two angles. So we have XZY, angle XZY, and angle ZYX, angle ZYX. Okay, so this one is the exterior angle. And these are the related remote interiors. Angles. All right, continuing. Number 2, name a second exterior angle and the related remote interior angles. So I'd like you to pause the video and go ahead and answer number 2 using either the yellow angle or the green angle, and then number 3 with the other angle. Okay, for number 2, the second interior, this is the green one, and this is angle ZYP right here. And then the related, then we have the related remote interior angles. So that would be this angle and this angle. So we have YZX, that's this one. And then the other one would be here, where X is your middle vertex, and we have ZXY. So these are your two remotes right there. If you haven't done the next question yet, go ahead, pause the video. The third exterior angle that we haven't worked with yet, that would be the yellow highlighted, and that is called XZQ. So we have XZQ, and if you called it RZQ, that would be okay. Then the two related remote interiors would be not Z, but X and Y. And then the correct way to write those are ZYX. Okay, so we have ZYX. Let's go over that one more time. ZYX. And then the other one is ZXY. So those are the remote interiors. Then we have question 4. Show that the measure of the exterior angle is equal to the sum of the related remote interior angles. So what we're going to do is we're going to show again where we did this here. We showed that the exterior is equal to the sum of the remote interiors. The exterior is equal to the sum of the related remote interiors. So there are 3 exterior angles, so 3 opportunities to prove it. So we've done one of them using this angle. Now we're going to do another example. So I have my drawing over here, And let's go ahead and do this problem. So let's take a look at angle X, Y, Z. We have angle X, Y, Z right here, and angle ZYP. That would be ZYP. So we've got ZYP and XYP. So what we have there is the exterior angle and the angle next to it forming a straight line, showing that that is 180 degrees. So we've got angle XYZ plus angle ZYP. And that is the angles on a straight line. That is the exterior angle and its supplementary interior angle. Next, we know that the sum of the three angles of a triangle is equal to 180 degrees. So let's write that down. We have angle XYZ plus angle YZX plus angle ZXY. So we have angle XYZ, that's right here. And then we have angle YZX, that's right here. And then we have ZXY, which is right here. So those are the three interior angles, and we know that that adds up to 180 degrees. So this is the interior, this is the triangle sum adding up to 180, and this is the straight line adding up to 180. And since they both equal 180, they equal each other. Then they have this common angle right here, and this common angle, let's clear this up so we can see better. They have this common angle right here, which is XYZ. So we have XYZ and XYZ. Since those are congruent, we can subtract them from both sides of the equation and it will remain equal. When we do that, we are left with the exterior angle ZYP, and then on the right side of the equation, we are left with the two remote interior angles, angle YZX plus angle ZXY. So let's look at that. Angle ZYP is your remote exterior angle right here. On the right side of the equation, we have the two remote interiors. YZX is right here, and ZXY is right here. When you add the two remote interiors, it is equal to the related exterior. So again, this is the exterior on the left. This is the exterior angle, and it is equal to the sum of the related remote interior angles. Let's take a look at example 1. Find the measure of angle X. Looking at your figure, notice that two of the interior angles are labeled 14 degrees and 30 degrees, and we are looking for the measure of angle X. And we want to use what we just learned about the exterior angles equaling the sum of the related remote interior angles to answer this question. So again, we know that x is the exterior angle, and we know that it is equal to the sum of the related remote interiors. So that would be 14 plus 30. So the measure of angle x is 44 degrees. Present an informal argument that proves that you are correct. Well, we know that triangles have a sum of interior angles that are equal to 180 degrees. We also know that straight angles are 180 degrees. So the measure of angle ABC right here would be 180 minus 44 degrees, which would equal 136 degrees. 136 degrees. So we know that because the sum of the measure on a straight angle is 180 degrees. The sum of the measures of angles on a straight line equal 180 degrees. We also know that the sum of the interior angles of a triangle are 180 degrees. So first we found the interior angle that was missing, 136 degrees, and then we can prove that, so on this side we have the straight line being 180 degrees, and then over here let's do 14 degrees plus 136 degrees plus 30 degrees equals 180 degrees. Example 2. Find the measure of angle x. Taking a look at your diagram, notice that two of the interior angles are labeled and the related exterior angle is the one that we are looking for. So go through a similar procedure and find the measure of angle x. And then we'll present an informal argument proving that you are correct. So pause the video and complete this problem. So I've added together my remote interior angles and I have 76 degrees. So that makes the measure of angle x 76 degrees. Now I want to present an informal argument showing that that is correct. So I need to know the sum of the interior angles. Well, I know that this is a straight line, so 180 degrees take away 76 degrees is equal to the measure of that interior angle, which is 104 degrees. Then, since this is 104 degrees, I know that the three interior angles will need to add up to 180. So 104 plus 44 plus 32 equals 180 degrees, which is also the sum of the straight line 76 plus 104. Again, this is the straight line, and on the right we have the triangle interior angles equaling 180 degrees. In example 3, find the measure of angle x. So we have three interior angles, two of which are labeled, and an exterior angle that we are looking for the measure. Pause and think about if this is exactly the same procedure that you've used in the last triangle problem. In the last problem, you were given the two remote interior angles and you were finding the exterior. Here, you are not given the two remote interiors, so you're going to have to use a different strategy. Well, take a look. You have a straight line, and one of them is labeled with the degrees. So you can use supplementary angles on a straight line to figure out the measure of angle x. So we just simply take 180 degrees. This is a straight line. So 180 degrees, subtract 121 degrees, and that gives us the measure of angle X, which is 59 degrees. Example 4, find the measure of angle X. Study the diagram, figure out what strategy to use, find the answer, and then resume the video to check your work. Notice on this problem that we're given just one of the remote interior angle measures and the exterior angle measure. For that reason, we'll need to subtract 45 degrees from the exterior angle to find the measure of the other related interior angle. So we've got the exterior angle of 129 degrees, and we know that it is the sum of the two remote interior angles. So to solve that equation, we can just subtract 45 from 129, and that gives us the measure of angle X, 84 degrees. You can also double check to make sure that that is correct using what you know about triangles. To check if this is correct, I would want to add the three interior angles, 45 plus 84 plus the third angle to get 180 degrees. 129 taken from 180 will give me the measure of that angle. So that gives me 51 degrees, and that proves that these three angles equal 180, so that you know your answer of 84 degrees was correct. On your own for number 5, find the measure of angle X and present an informal argument showing that your answer is correct. Pause the video, solve the problem, and resume it to check your work. Angle X is an exterior angle, and the two related remote interior angles are given. So the measure of angle X is equal to the sum of 89 plus 28. So the measure of angle X is equal to 117 degrees. An informal argument showing that your answer is correct. Okay, we know that the angles on a line are equal to 180 degrees. So a straight angle is equal to 180 degrees. And we know that the triangle sum of the interior angles is also 180 degrees. And the triangle sum, we know two of the angles. We have 89 plus 28. And on the straight angle, we know 117. And this missing angle is the third interior angle. So we can subtract from 180, 117 to find the measure of our angle, and I believe that gives us 63 degrees. And also these two angles add up to 117 degrees, and if we subtract that from 180, 63 degrees, proving that your answer of 117 degrees is correct. Number 6, find the measure of angle X, present an informal argument showing that your answer is correct. So on this diagram, we have an exterior angle, and we are given the measure of the remote interior angles. So I want you to solve this problem and present your informal argument. Pause the video, solve the problem, write out your informal argument, and then check your work. The measure of angle X is the exterior angle, and the two remote interior angles are 59 and 52. We add those together to get the measure of the exterior angle, which is 111 degrees. Then our informal proof. We know that on the left side, the sum of the interior angles of the triangle, right here, is 180 degrees. And then on the right side, we have the exterior angle plus the interior angle right here on a straight line is 180 degrees. So we figure out what this angle is, and I did 180 for the whole triangle, take away the other two interior angles, and that gave me 69 degrees for the third interior angle. So I used the 69 degrees along with the other two interior angles to get the triangle sum of 180. And then on the right side of my equation, I used this straight angle of 111 degrees plus 69 degrees equals 180 degrees to show that my answer is correct. Pause the video and solve problem 7. Present an informal argument showing your answer is correct. Resume the video when you are ready to show your work or check your work. This is a straight angle, and we know that that's 180 degrees. So 180 degrees, take away 79 degrees is 101 degrees. The measure of angle x is 101 degrees. I know this to be true because a straight angle is 180 degrees. 180 degrees is equal to the measure of angle x plus 79 degrees, and our angle x plus 101 degrees, which is what our answer was, and 79 plus 101 adds up to 180 degrees. Number 8, find the measure of angle x, present an informal argument showing that your answer is correct. Pause the video, solve the problem, and then resume to check your work. Looking at this diagram, I see that the exterior angle is equal to the sum of the remote interior angles that are related. So I know that the measure of angle x is equal to the sum of 71 plus 74. So the measure of angle x is equal to 145 degrees. An informal proof showing that this is correct. I know that the sum of the interior angles is equal to 180 degrees. The sum of the interior angles are 71 plus 74 plus the third interior angle. The third interior angle is found by subtracting the other two angles from 180. So that is 35 degrees. So we have 35 degrees. This adds up to 180 degrees. That's the triangle sum. Then on the right side of the equation, we have two angles on a straight line. 35 plus 45 equals 180 degrees as well, proving that my answer of 145 degrees is correct. Question 9. Find the measure of angle x. Present an informal argument showing that your answer is correct. Pause the video and solve the problem. Angle x is the exterior angle. The two related interior remote angles are included, 107 plus 32 degrees. We add those together to find the sum or to find the measure of the exterior angle, and that gives us 139 degrees for the exterior angle. To prove that our answer is correct, we know that the straight angle is going to equal 180 degrees, and the three interior angles are going to equal 180 degrees. So let's find the missing angle. We have 180 minus the sum of the interior two angles, which was 139 degrees, and that gives us 41 degrees. So 41 degrees is the third angle. So 41 plus the exterior angle of 107, that gives us the straight angle of 180 degrees. And then the three interior angles are 41 plus 107 plus 32. And this equals the triangle sum of 180. And that proves that our answer of 107 degrees or rather 139 degrees is correct. Sorry, let's go back and fix that. That was right here. That's 139 degrees. So when we add that together, we get 180 degrees. Number 10, find the measure of angle x. Present an informal argument to show that your answer is correct. Pause the video, solve the problem, and resume it to check your work. The exterior angle is equal to the sum of the remote interior angles. So we have 156 degrees, take away 81 degrees, and that is equal to the other remote interior angle, which is 75 degrees. Then, in an informal argument showing that our answer is correct. So we have the straight angle is equal to the triangle sum of the interior angles. Our straight angle is 156 plus this acute angle. Let's go ahead and figure out what that is. 180 degrees, take away 81, take away 75 is equal to the small remaining angle, which is 24 degrees. So we had 180 take away 156 is equal to 24 degrees. So that gives us this angle. So the straight angle is 24 plus 56, or rather 156. And then the interior angles are 81 plus 75 plus 24. And this equals 180 degrees. On the left, it equals 180 degrees. And here we have the exterior angle is equal to the sum of the two remote interior angles. So we have proven that our answer is correct. Here we go. In this lesson, we learned another proof as to why the interior angles of a triangle are equal to 180 degrees with respect to a triangle being exactly half of a rectangle. We learned the definition of exterior angles and remote interior angles. The sum of the remote interior angles of a triangle is equal to the measure of the related exterior angle.